So in our last lesson, we talked about the volume of these three-dimensional shapes that we started looking at, and specifically we were looking at prisms, which, just as a reminder, the prisms were a three-dimensional shape where two sides were exactly the same size. They also ran parallel to each other, and then they're kind of just connected. And so our notes from the other day were talking about finding how much space is on the inside of these. All right, and again, those prisms had two sides, like the triangles on opposite sides, that are exactly the same. They run the same direction, they're parallel, and then they're just connected, and that connection point was the height. So if we had the trapezoids, one on each side, they're connected by the 6. In a rectangular prism, we talked about there can be all different bases, depending if you want to call the top and the bottom, the left and the right, the front and the back. You have lots of different options of pairs of sides that are parallel and the same, but they are still just connected. So if you called the top and the bottom the bases, the 4 would be the height. That's the connection point. So today we're going to continue working with the prisms, the rectangulars, the triangulars, and the trapezoidal, but we're going to be looking at surface area instead of volume. So volume was how much space is on the inside. How much can you fit on the inside? If you were filling it with water or you're filling it with anything, how much can you fit inside the box? Today we're looking at surface area. And that's the amount of material needed to create the object. So we're actually talking about the physical outside. So not the space on the inside, we're talking about the physical outside of the box. So if you were running a company that created cardboard boxes, how much cardboard is needed to actually make the outside? That's going to be the surface area. Or if you're wrapping it, wrapping paper, how much wrapping paper? How many square yards of wrapping paper do you need to cover this? Or eventually if we get to cylinders, how much metal is needed to create a can of soup or a can of tuna fish, whatever. Okay, the actual outside, that's the surface area. So we don't care about the space on the inside. We're actually just looking at the area of each and every side. So the nice thing about these is there's no formulas to memorize necessarily. You're literally just going to find the area of every single side. So it's the area of all sides. So every one of these shapes is going to have a different number of sides. So they're all going to have a little bit different amounts of work. But you literally just find the area of every single side, and you just add it up. And it's the total area of all the sides. That's the surface area. So in terms of memorizing what to do, it's pretty simple. It actually takes a lot of work, though, sometimes. Although when there's a lot of matching sides, you don't actually have to run the numbers for every side. So if we figure out what's the area at the top of this box, then we already know the area of the bottom of the box. So we don't have to run all the numbers again. All right, so starting on this one, we have a top and a bottom that match. So I'm going to label that here. And the most important part of the work today is going to be organizing all of your data and all of your work. Okay, so we're going to show our work for the top and the bottom, finding the area of that shape right there. You've also got the left and the right. I'm going to show the work underneath here. And then you've also got the front and the back. Now I do want you to organize your work like this, but I don't want you to stress too much over what's the top and the bottom, what's the left and the right, what's the front and the back. Okay, as long as you cover all the sides, we're good. So let's start with the top and the bottom. So we're dealing with a rectangle. Let's draw the picture real quick. So if you trace the top of this box, three-dimensional box, it looks like this. So if we pull that out, this side of it is 2, and this side of it is 3. And so area for this rectangle is just base times height. So it's just 2 times 3. And so the area is 6. Now that's just for one side. Now since we have a top and a bottom, we're going to double this. So the total area of the top and the bottom is 12. 6 on the top, 6 on the bottom. Pretty simple. Now the left and the right. So again, we've got a rectangle. It's over here if we traced it. It's kind of hard to see based on the way this shape is sitting. But the whole bottom run of it is 3. And the tricky part to see is this one. So we follow it down, that's 3. Following it up, you can find that length right here. It's going to be 2. So area is base times height. This one again is 3 times 2 or 2 times 3. The order doesn't matter. So the area is 6. And again, just the left is 6, and the right is going to match it because both sides are going to match. So the total area of the left and the right is 12. All right, now the front and the back are these little squares right here. So the bottom, if you traced it out, is 2, and then the height here is also 2. So it's 2 by 2. Area is base times height. 2 times 2. Front is 4, which means the back is also 4 for a total of 8. So we've covered all 6 sides here. 2 of them are 6. The other 2 are also 6. The other 2 are 4 for a total of 12, 12, and 8. We're going to just add all those sides up for a total area of 32. And we're talking area now, so we're not talking about space on the inside, which is volume, which is always to the 3rd power. So area is always to the 2nd power. So this is going to be yards to the 2nd. And if you look at what we multiplied, yards times yards, yards times yards, yards times yards, we always multiplied 2 numbers. So it's to the 2nd power. And that's it. Now it's a lot of work to show, but there's nothing really difficult. We just multiplied base times height, base times height, base times height. So not too bad. All right, let's look at the triangular prism now. So on these, you've got 2 matching sides, the triangles on the top and the bottom. And then you've got 3 other sides that don't match. So you've got this front side, you've got this back side, and you've got kind of this left side. And they're all rectangles, so they're just base times height. We just need to make sure that we do each one separately and we get all the measurements right. But first, let's start with the triangles. And I'm just going to label them triangles. You can call it top and bottom, because that's what they are. Right? Those triangles are the top and the bottom. But I'm just going to label it triangles. So if I drew that triangle, so when this triangle is drawn out here, we always want to find the base and the height, and you got to look for the 90 degrees. And so you don't really see it on the top triangle. You got to find the matching bottom triangle. And you can see the 90 degrees is up here in this little corner. So if I was redrawing this triangle, it's up here in this little corner. And the 2 sides that hit at 90 degrees are going to be your base and your height. So those are the 2 important sides. This side's 6 right here, and this side's 8. Now this side's 10, but we don't need it, so I'm not even going to put it in the picture. It is 10, but the base and the height are right here, and those are the only 2 lengths that I need to find the area. So remember, your triangle formula is 1/2 base times height. So it's going to be 1/2 6 times 8. It does not matter which one you call the base and the height, so 6 times 8 or 8 times 6. Okay, half of 6 is 3. 3 times 8 is 24, and you can plug all that in your calculator. And remember, you've got a triangle on the top. That's 24, and you have a triangle on the bottom. That's also 24. So there's 2 of them for a total of 48. All right, so far we've doubled every single one of the numbers that we got because there was a matching side. Now you need to be careful. You don't necessarily do that every time, so you still got to think. So as we go ahead and do all of these rectangles that run around the outside of this shape, they don't have matches, so we're not going to double them. So let's start here with the front. I think that's the easiest side to start with. So this front right here is a rectangle, the front of this shape. And according to the numbers, although the picture doesn't look like it, this is actually a square because the bottom of it is 10. And the height of it, although it doesn't look like it should be the same length, it says it's 10. Alright, so this is actually a square. Base times height, just 10 times 10. So the area of that one is 100. Now it does not have a matching one on the other side, so I'm not going to double it. The area here is just 100. Alright, we got 2 more sides. We've got this back rectangle and this side rectangle. Let's go to the back. And again, you need to be labeling your work like this. Just random multiplying and adding all over your paper, and then a final answer is not going to be accepted. I need organized sections for all the different pieces of this. Now the back, you traced it. It's a rectangle. You can see the top of that rectangle is 8. And then this height is 10. And so it's base times height. You're just going to multiply 8 times 10. That's 80. It does not have a match anywhere else, so we're not doubling it. It's just 80. And we're almost done. We've got one more side. This one is a little more difficult to see, but it's a rectangle over here on the left side. So I'm going to call this the left. It's once again a rectangle. And if you follow the top of that rectangle right here, it's 6. So I'm going to put the 6 right here. And then we have to figure out this height right here. So I don't see a label here and I don't see a label here. So somewhere else in the picture there's a matching piece to this. And it's this 10. 10, 10, 10. They're all the same. So the height of this is 10. Now one trick that's always going to be true on these triangular prisms is the height of all your rectangles will be the same because it's 10, which is the height of this rectangle, which is the height of this rectangle, which is also the height of this rectangle. So if you ever get stuck and you just don't understand the picture, just know that the height of all of your rectangles is going to be the same. So we have a 10 by 10, we have an 8 by 10, and we have a 6 by 10. That may help you out. So a 6 by 10 is going to be 60, base times height, 6 times 10. It doesn't have a matching side, so it's just 60. All right, we're going to add all those up for a total of 288 square centimeters. The most we ever did was multiply 2 centimeters together. Now we multiplied 3 things here, but the half isn't representing centimeters. It's the 6 centimeters times the 8 centimeters. 10 centimeters times 10 centimeters, so it's centimeters squared. Okay, last one now. Still the same idea. We just have trapezoids now. We've got a top and a bottom that are different, and then we have a left and a right, and those are going to match. So these two little sides match, plus the trapezoids are going to match. Let's always start with the hardest part, and that's the trapezoids. There's 2 of them. You've got the one here in the front, and you've got a matching one over here in the back. So our trapezoid formula is 1/2 base 1 plus base 2 times the height. If I was going to separate that trapezoid, what I need is base 1, base 2, and the height. I don't care about these little sides. They're not going to help me. So the bottom, one of my bases is 4. The top, be careful. A lot of people will call it 8. 8 is this line over here. This top piece is going to match this top piece over here. So it's 7. And then my height is this little dotted line. Remember, it's got to be 90 degrees straight down. And that's 2.6. So when I plug everything in here, base 1 and base 2 is 7 and 4. It doesn't matter what order you put them in. And the height is 2.6. And so you're going to run these numbers. 7 plus 4 is 11. You're going to multiply that times 2.6, and then you're going to take half, or you can do it in whatever order you want. You can plug it all in, 0.5 times 11 times 2.6. Just a reminder, if you're going to try and plug all of this in your calculator at once, you need the parentheses so the calculator knows to add these first. If you don't, they're going to add last, and you will get a different answer. So if you insist on putting everything in the calculator, make sure that you put the parentheses. Otherwise, go one step at a time. 7 plus 4 equals times this times this. All right, total here is 14.3. And again, there's 2 of these, 2 matching sides. So if one of them is 14.3 and we have 2 of them, you got to double that. And so that's 28.6 for my total area for 2 sides there. 28.6. Okay, now we have a top, a bottom, and a left and a right. Let's do the left and the right since there's 2 of them. And you don't have to do them in the order that I'm choosing to do them. But the left and the right are these little rectangles. So you've got this piece and you got this piece. So if you follow, this 8 is going to match all of these. So you got the 8 on the top, 8, 8, and then the height is 3. So this is just going to be base times height, 8 times 3, 24. And now there are 2 of these, they match. So we're going to have to add a 48, 24 times 2. All right, we're not going to have enough time in this video to finish it, so we'll pick up right on the next video. So I changed my mind. Instead of going to a whole new video, let's just throw all the work up. If you need to pause it to copy it, you can pause it. But just to run through it, the other 2 sides that we needed were the bottom and the top. So if you look at the bottom, this piece is 4, and then this side piece is going to match here, and it's 8, so it's 4 by 8. Multiply and get 32. And then on the top, you've got an 8 by 7. this whole thing up here, which is 56, and then you're going to add them all up just like you did on all those other shapes.